Welcome to hyperbolas, the last of our conic sections we are going to be focusing on. So a quick definition, a hyperbola is the set of all points whose difference in the distance between 2 points called the foci remains constant. So an ellipse, it was the sum of those distances that remained constant. Here it is the difference, and it's technically the absolute value. Right. So in terms of the graph, we have our two foci. And some set difference in distance. So we could say pick points symmetric along the same line as those points on the inside. And then if we think about the difference in the distance, so we take our distance D1 and D2. We have that the absolute value of D1 minus D2 is a constant D. It turns out that these points make they're not quite parabolas, but two shapes that look similar to parabolas that open out around the foci. So we have two foci, each one itself is a focus. The axis that runs through the foci that the hyperbolas open around are known as the transverse axis. So the transverse axis is the line that runs through the foci. If we draw a perpendicular line, this acts sort of as the other axis of reflection. We call this the conjugate axis. So the perpendicular axis of symmetry is called the conjugate axis. I'm not going to work through finding the equations in this case. Our standard equations, we have two of them. If we have for a horizontal transverse axis, we get the equation x minus h squared over a squared minus y minus k squared over b squared is equal to 1. For a vertical transverse axis, we essentially swap the x and y. So we have y minus k squared over a squared minus x minus h squared over b squared equals 1. So this looks very similar to the ellipse equation. The big difference here is that instead of addition, we now have subtraction. Our center for both of these is HK. Our C, which is if the distance from the center to the focus. So if C equals the distance from our center to a focus, then we have that C squared is equal to A squared plus B squared. So similarly to how for an ellipse, it was the positive difference. In this case, it's the sum. A very useful fact for graphing parabolas is that we can draw lines that give us our sort of diagonal asymptotes, essentially, for our hyperbola. So if we have our transverse axis, if we take our center and then we go out distance A along our transverse axis, and we go distance B along our conjugate axis, and we create the rectangle with center at HK that has width or length 2A and width 2B. Our hyperbola just touches along that transverse axis at the edge of the rectangle and extends out, and it follows diagonal asymptotes that go straight through the corners of the box. So you can very quickly get a sense of the overall shape of the hyperbola by drawing this box and then drawing the diagonal lines. So it doesn't matter if it's the vertical or horizontal version of this. Again, if this is our transverse axis, this is what we get. So for example, let's consider the parabola graphed below, which has center at 2, 3. And the box goes from x equals -1 to x equals +5, and from y equals should be from sorry, not quite perfect here. From y equals 2 to y equals 4. So in this case, our job is to find an equation for the hyperbola, then determine the location of the foci. So when we do this, again, our center is at 2, 3. So that's our HK. Our transverse axis is horizontal. We know that our distance on the transverse axis from the center to the edge of the box is distance 3. Our vertical distance from the center to the edge of the box is 1. So we know we are looking at x minus h squared over a squared minus y minus k squared over b squared is equal to 1. We know our h is 2, our k is 3, our a is along the transverse axis, that distance from the center to the edge of the box. So our a is 3, our b is 1. So we are looking at x minus 2 squared over 3 squared minus y minus 3 squared over 1 squared is equal to 1. So this would be our formula for our hyperbola, or our equation for the hyperbola. To find the foci, we have c squared is equal to a squared plus b squared. So c squared is equal to 3 squared plus 1 squared, otherwise known as 10. That means that c is the square root of 10. Our foci fall on the transverse axis. Distance c from the center. So our center again was at the point 2, 3. So we will go c to the right would be plus square root 5 going to the right. Going to the left, we subtract square root 5. Again, we're going left and right because our transverse axis plus is horizontal in this case. So our foci would be 2 minus root 5, comma 3, and 2 plus root 5, comma 3 for our foci. So that is how we can go about finding the equation from a graph. Note, if you have the equation, you can then create this box and draw your graph from there. Just pay attention to whether you have a horizontal or a vertical transverse axis. Finally, just like with ellipses, we do have eccentricity. And that eccentricity is just, once again, C over A. So in this particular case, in this example, eccentricity would be square root 5 over 3. So this is our this is hyperbolas. In the next video, we will look at some reflective properties of all 3 of our main conic sections. And then that will be it for conic sections.